we are live now.
Okay. Good morning, good afternoon, all present here on a virtual dais. Today's resource person, Dr. Sanjay Pohekar, our principal, Dr. Sanjay Bokade, Vice Principal, Dr. Sanjay Deshmukh, Head of the Mechanical Department, Dr. Rajesh Kale, teaching and non-teaching staffs, and all the participants. I, Professor Chetan Rane, on behalf of MCD's Rajiv Gandhi Institute of Technology and Department of Mechanical Engineering, welcomes you all for the last day, second session of AICT AQI sponsored online 1 week short-term training program on recent trends in energy management and audit. Today we have our resource person for this STTP, Dr. Sanjay Pohekar, with us. He will speak on energy audits of boilers. I take opportunity to introduce our today's resource person, Dr. Sanjay Pohekar. He graduated in mechanical engineering in 1989, did masters of technology in engineering management in 1994, then postgraduate diploma in human resource management in 2000. He obtained doctorate degree in mechanical engineering in 2004 from Birla Institute of Technology and Science, Pilani. He is a professor and head of research program in Symbiosis Center for Research and Innovation, deemed University Pune. He was also looking after the PhD program of BITS Pilani during tenure at BITS Pilani. He has taught in various continuing education programs of National Thermal Power Corporation, Bharat Forge, Reliance Energy, Aton Corporation, Lupin Laboratories, Tata Autocam between 1999 to 2005. He has 30 years of experience in teaching, research, and industry. He has conducted management development programs for the officers of Ministry of New and Renewable Energy Sources, India, and Process Stream Engineering. He has 25 international journals publications to his credits in addition to several conference proceedings. He was on reviewer board of Elsevier, Science, Springer, InterScience, IACSIT, Desolation Society of USA, Nova Science Publisher, and Willy. He was referee for scientific awards of Turkish and Japanese governments. His papers have attracted more than 3,200 citation with H index of 13 as on date. Sir, I welcome you, sir, and thank you for joining with us today. I request you to enlighten us with your words of wisdom. Sir,
Okay,
you
thank
can
you.
start your
Okay,
session, sir.
okay, thank you very much. We have got about. Can somebody tell me how many participants have joined? Am I audible?
Yes, sir, you're
Yes, sir.
audible.
Okay. Okay. So the topic which is given to me is energy audit of boilers, but I have modified it little bit. What I am saying here is energy saving in boilers and thermal utilities. Uh, Thank you for giving a good introduction. Uh, so, what I am planning to present in front of you is what are the avenues of conservation of energy in boilers. Also, I will share with you certain case studies which are basically success stories of energy saving in various thermal utilities, maybe furnaces, maybe insulation breakage, so on and so forth. In fact, the entire process of energy auditing has been covered in the STTP elaborately by various people, various resource personnel. See, let me just tell you what are the basics of going about energy audit of any utility. Number one, the industry which you are going to choose for doing the energy audit shall be categorized under energy intensive industry. That means it should be consuming large amount of energy for producing unit output. So if you take the engineering industry where only fabrication work is going on, or where only turning facing kind of operations are going on, that industry may not be referred to as, as an energy intensive industry, whereas the industry where the amount of energy consumption is large, then we have to categorize it to be as an energy intensive industry. So chloralkali, glass, ceramic, cement, power plants, the and many process industries come under the category of the energy intensive industries. Uh, and one of the important utility in an energy intensive industry is the boiler. And the second alternative entity in an energy intensive industry is thermal utility. So they are very basically we need to conserve energy in this one. As of now, you might be aware that we are having two types of energies used in the industries: lower grade energy and a higher grade energy. Higher grade energy is electricity, which is easy to control. And since we have converted lower grade into a higher grade energy, we have already compromised on the energy efficiency matters. But then electrical motors, thermal utilities, which are working on electrical principles, the controls are better. A thermal energy, being a low grade energy, has got a tendency to dissipate in the nature, and that's how it becomes difficult to control. So how can we control the energy efficiency, or how can we basically quantify and conserve the energy in thermal utility? That is the topic of the day. Let me remind you of one fact, that if you cannot control anything, if you cannot quantify anything, you cannot control anything. This is a golden rule in engineering. That is the basic purpose of energy audit. See, like financial audits we are doing, we will be doing energy audits wherein we will take an account of, let us say, if I have supplied 100 units of energy, where all these energy units are going. And if at all the energy units are going, say about 60% of the energy units are going in thermal utilities and boilers, and if you can make an attempt to save it over there, the entire energy saving in your plant will be substantial. Whereas if you try to save energy in lighting and lighting based utilities, which are very miser in consumption, 5%, 6%, at the max 10%, so there is very less say, I would say, very less potential of saving of energy in a particular factory. uh, and I am talking of the situation wherein we were trying to save energy in lighting, etc., when we were using this incandescent lamps, and then we switch over to CFL lights and like that. Now we have switched over to LED lights, and the consumption and conservation principle has further decreased. So my point, which I am trying to drive before you, is boilers and thermal utilities are basically consuming large amount of energy in a major energy intensive industry, and there is a potential of saving over there. The objectives of the session are as follows. We are trying to learn here the types of boilers, its objectives, and its accessories and parts. But then I am not just telling it for the sake of no teaching you boiler types, is all those issues, because they are again linked to the saving of energy. We should know also the boiler operation practices adopted by the industry in general. And so we should know the role of operating parameters, and how can we make the boiler operation optimum. So these are the three four purposes. They may be directly addressed in my talk, or they may be indirectly addressed in my talk. So if you look at the boilers, boilers are known as steam generators. They are producing steam, which are used in process and power generating units. And basically it's a fluid. Boiler produces steam, which is basically a thermic fluid, which can be taken to places, which can be utilized for heating. Maybe you can heat cane juice, maybe you can use it to run a turbine and generate mechanical energy, so on and so forth. So efficient generation of steam is a very important issue in process industry. When you are using the boilers for power generation purposes, we call them to be power boilers, and process boilers generate normally the steam for process use, and excess of the steam which is produced is useful for the power generation. According to that, we have got topping cycle and bottoming cycle. Either you can use the steam basically for power generation, and the steam which is useful, or say Available after power generation can be utilized for the purpose of process heating. Or the other choice is we basically use the steam for process heating, and whatever is the low quality steam available thereafter can be utilized for power generation. The farmer is better. In fact, attempts have been made to convert the process industry like sugar industry into a power plant, and power plant is connected to a sugar industry, and that kind of no combinations have been tried in the name of cogeneration. In fact, a tri-generation concept has also come. All these cogeneration units will be basically involving boilers. All of us are account those who have learned mechanical engineering, chemical engineering, they will be all acquainted with these two kinds of boilers called as fire tube boilers and water tube boilers. Fire tube boilers are there. Simply, how can we define fire tube boilers is fire inside the tube. We are not going to put fire inside the tube, but the hot flue gases which are basically formed after burning of any fuel, they are, if they are inside the tubes, then we call them to be fire tube boilers. And water tube boiler means water is inside the tubes and the flue gases are outside the tube. So water in the tube is known as water tube boilers. Fire or flue gases in the tube is known as fire tube boilers. Now this is a fire tube boiler layout. In this, hot gases pass through the tubes, and boiler feed water is in the shell side and is converted into the steam. So water outside and steam inside is the typicality of a fire tube boiler. If you look at a typical water tube boiler, in the water tube boiler, boiler feed water, that is BFW, flows through the tubes and enters into the drum, and water is circulated through the tube, get heated and converted into the steam at the vapor space in the drum. So flue gases are outside the water. The water is there in the tube and flue gases are outside the tube. Now these kind of boilers are better boilers. These kind of boilers can be called as more efficient boilers. The selection of boiler also depends upon the pressure. Fire tube boilers, typically these boilers are selected when the steam demand and pressure requirements are within low 1 to 5 kg per centimeter square gram, capacity of 500 kg per hour to 30 ton per hour of low pressure steam, and they are normally utilized for the purpose of process heating, or in case you have got utilities which are driving, uh, mechanical drives are there, which are based on steam drives, then we can use this kind of boilers. However, the basic thermodynamic principle says that higher the pressure of operation will be getting more and more efficiency. Lower the pressure of operation will be getting lower and lower efficiency. If you look at the TS diagram of any boiler or steam generation matter, if you are operating at lower pressure, the enthalpy required for converting the water, saturated water, into a saturated steam will be pretty large. And as we increase the pressure and go on the upper side of the uh, TH diagram, you will find that as the temperature and pressure rises, the enthalpy of conversion from saturated steam to saturated vapor decreases, and the enthalpy decreases, so we can convert the steam very efficiently into a higher pressure steam with less consumption of energy. And then there is a point wherein the liquid steam or the liquid water can be converted into steam directly without intermediate boiling point. That point is known as the critical point, and that pressure is 22 megapascal. However, there are boilers nowadays which have gone much above that. So from low pressure boiler, we have gone to a higher pressure boiler. From higher pressure boiler, we have gone to a critical pressure boiler. And now the world is, we have gone from the critical pressure boiler to a supercritical pressure boiler. That means the energy requirements of conversion of no, saturated liquid water into saturated steam reduces drastically, and efficiency improves drastically. If you look at the water pressure boilers, wherein we will be employing water tube boiler, these boilers are selected when the steam demand as well as the steam pressure requirements are very high. So above 10 kg per centimeter square gram and 50 to 350 tons per hour of steam, which is called as the medium pressure or high pressure requirement of steam. If it is there, then we'll be going to a water tube boiler. So critical pressure boiler, supercritical pressure boilers, normally they will be categorized into this water tube boiler. The water tube boilers will be employed for that purpose. The point which I am trying to drive here is we need to understand the thermodynamics of steam power generation. Higher is the pressure of operation, lower is the enthalpy requirement, and we can go for higher and higher efficiency boilers. In fact, I myself have audited few boilers which are lower pressure boilers. If you just look at say 1906 era, that is the beginning of 20th century, the industry was employing lower pressure boilers, and conversion efficiency of boiler was very low as 6%, 7%. In the beginning of 21st century, we are we have started using higher pressure boilers, critical pressure boiler, and supercritical pressure boilers, and normally the combustion efficiency in the boilers is now in the range of about 93, 94%. So in 100 years of development of boiler, the efficiency has increased from 6 7% to 93 94%. It doesn't mean that at the beginning of 22nd century we would have crossed 100% efficiency. That is not possible. The point which I am trying to drive is higher the pressure, higher the efficiency, and higher the steam production rate. However, there are material constraints. To operate the boiler at higher pressure, we require higher proficiency of the boiler engineer, higher control will be required, and if you cannot control it, then the boiler can be disaster. But then the engineering has come to such a level that we need not worry much about it. In fact, one of our couple of our friends are working in the power plants which are working at a higher pressure boiler, critical and supercritical pressure boiler, and the steam generation is done very efficiently. Uh, the boiler fundamentals tells us that everything boils down to basically converting as much heat available with us into steam as much as possible. So the combustion process will be basically requiring the air, and moist air can be heated by the waste flue gases which are otherwise flared or which are otherwise vented out to the atmosphere. So this kind of particular utility we can have in the boilers, which we call it to be air preheater. As the name suggests, we'll be preheating the combustion air by the flue gases which are otherwise going to be vented out in the atmosphere doing the thermal pollution. So this kind of air preheater as an accessory we can use in the boiler. Then we can use economizer in the boiler, wherein boiler feed water can be heated by a flue gas. Then we can have a superheater wherein the steam can be superheated beyond the boiling point or beyond 199.96 degrees Celsius, but we have to basically increase the pressure. The pressure can be increased in a superheater. Then we can now these all three are called as the boiler accessories, and the energy conservation in boilers will be aimed at how can we efficiently employ, economically employ the air preheater in the boilers. So we'll have to audit the boiler, find out how much is the heat otherwise going waste through the chimney in the boiler, and if that heat can be recovered for which will require an audit to be done. If you do the audit of energy audit of boiler and find that substantial quantity of heat is going waste and that can be utilized in the air preheater, then we'll be basically employing the air preheater. But then you simply cannot put air preheater because it is already documented in the textbooks of thermodynamics or boiler. You simply cannot employ air preheater in the boiler. We'll have to basically do the energy audit of boiler, find out how much is the quantity of heat which is going waste through the flue gases, and that heat can be captured in the air preheater. If at all certain heat is still available with you, we can capture it in the economizer. Now, how to decide whether economizer is to be employed first or air preheater is to be used first? That is a decision to be taken by the help of that is a decision which is to be taken by the help of the heat transfer coefficient available basically at your disposal. So any gas to gas heat exchange coefficient will be less. So air preheater will not allow us to basically employ recover more heat, whereas economizer will be allowing us to recover more and more heat. Then there is another utility which accessory which we call it to be induced draft or forced draft fan. See, induced draft or forced draft fan means if you allow the combustion to become efficient, and combustion efficiency can be improved the moment you are supplying sufficient amount of air for combustion to happen. So we can supply it with the help of a forced draft situation or induced draft situation, and that kind of boiler accessory can be employed. Uh, if at all you are using liquid boilers, that is oil fired boilers, then we can have uh, burners. Efficiency of burners can be employed better because all the time we may not be using coal fired boilers. Many times we may use oil fired boilers, LED boiler, light diesel oil kind of boilers, wherein we require basically the automation of the fuel. Then damper control has to be there so that in case the draft is to be maintained, we have to have a damper control, and we need to basically monitor the process of combustion, and we need to monitor the oxygen which is being supplied for the process of combustion. Now we are monitoring how much is the oxygen in our body. Similar way, the oxygen needs to be monitored in the boiler houses. Now let me just tell you, the air preheater will be basically heat exchanger of this type, wherein the flue gases which are otherwise going waste can be utilized by using a shell and tube air heat exchanger, and it can increase the efficiency of the boiler house by 9 to 11%. However, I am telling you the efficiency improvement of 9 to 11%. How do you quantify it? You may get 9 to 11% or you may get lesser than that. All these things will be dependent upon what is the amount of heat which is otherwise going waste through your chimney gases. Higher the temperature of chimney gases, higher is the heat recovery potential, and we can employ air preheater for capturing the heat which is otherwise going waste. The economizer layout is again a shell and tube heat exchanger, wherein you can recover again substantial amount of heat. Similar position, you employ a superheater. Superheater will be, however, after the main drum. Superheater is designed to superheat the steam. So typically we'll have got very low diameter tubes. Saturated steam coming out from the boiler drum, and a flue gas is used to superheat the steam. This results in the fuel savings in the boiler operation. So air preheater economizer, superheater. These are called as heat recovery equipment. They can be employed. Induced draft, forced draft can be employed, and oxygen monitoring can be done. Combustion air monitoring can be done. There can be several measures which can be employed for efficiency improvement of boilers. Now, how do you account? Since the workshop is addressing the energy audit, and the meaning of energy audit is to account for. So, how do you account the energy input output from a boiler house? So, energy input output of a boiler, if you try to monitor, the input will be air, the input will be fuel, input will be boiler feed water, and we need to count how much is the enthalpy available in the fuel, that is the heat content available in the fuel, how much is the heat content available in the air, and this heat content, if you just add it up, will be getting basically the enthalpy of input, and you will be getting the enthalpy or heat of combustion. If you look at the output is coming in terms of primarily the steam produced from the boilers. Some heat is going loss here and there. We need to account the losses, and majority of the heat will be getting lost in the flue gases which are going out of the chimney. So enthalpy in the flue gases, heat losses by convection and radiation, all those things need to be accounted. And if you account all these things, which will require basically a lot of measurements to be taken, logbook need to be maintained. If you can do that, then we can find out we can deduce a sheet which we can call it to be energy input output of a boiler. And the moment you make a loss, like now we maintain a financial sheet wherein we write down the gains on one side, the losses on one side, and if you just try to weigh the gains and losses, the losses, and wherever we are making more losses, if you try to conserve those losses, we can get better efficiency. And this entire process is known as auditing process. So let us find out how much is the heat input given by the fuel, air, and how much was the heat input available in the feed water, and the same heat input, thermal energy is getting conserved. The total energy which is available in the air, fuel, and feed water is going to be converted into enthalpy of the steam, then enthalpy available in the heat losses in the flue gases, and any heat which is getting lost from the boiler shell or convection and radiation within the shell. So if you account all these things, then you get the picture on both these sides. How much is the heat given to the boilers, and how much is the heat given out in the flue gases, etc. If you make account of it, we'll be getting to know how much are the losses. And if you can control the losses, you will be getting better efficiency of the boiler. And this is called as energy accounting or energy audit of the boiler. If you look at the performance assessment, the purpose of performance assessment of the boiler, the purpose is to find out efficiency of the boiler, and as you are aware, any efficiency calculation will be requiring heat output versus heat input. Heat output will be going into the numerator, and heat input will be going into the denominator. And if you just calculate heat output by heat input, we'll be calculating, we'll be doing the basic performance assessment. Also, one measure which is performance assessment measure is to find out evaporation ratio. How much is the kilogram of steam required, kilogram of steam generated per kilogram of fuel consumption. And lower the kilogram of fuel consumption and higher is the kilogram of steam produced, we can say the evaporation ratio is better, and any better evaporation ratio is always advisable. So two performance measures I can tell you at this moment. we should basically have more and more efficiency and higher and higher evaporation ratio. In fact, you might have done or studied by now a term called as specific energy consumption. Now, specific energy consumption means what? How much is the heat required or how much is the energy required to produce per ton or per kilogram of the yield. So if let us say you are producing steel, for producing 1 kilogram of steel, how much is the kilowatt hour of energy? You may use thermal energy, you may use various forms of energy, but how many kilowatt hours of energy are being spent to produce 1 kilogram of the particular steel? That will be called as specific energy consumption of that steel mill. And if lower is the specific energy consumption, then your industry is running efficiently. So if you look at the steel industries in the Indian continent, we can say 1 kWh per kilogram of steel produced is the specific energy consumption of Indian steel industry. However, if you look at the Japanese steel industry, they may be consuming only zero point 0.7 or zero point 0.8 kilowatt hours per kilogram of the steel produced in their country. That means they are more efficiently producing steel in their country. They may be doing by more quantity production, less losses, so on and so forth. Now let me tell you how do you account all these things in boiler. This will be counted by two measures. One is the efficiency measure and the second is the evaporation ratio measure. So per kilogram of fuel consumption, if your steam produce is larger, then the evaporation ratio is found to be higher and higher. Now, how do you account for the measurement? There are two methods of assessment. One of the measure of assessment is heat balance to be used for this purpose. Direct method. Just find out quickly without doing much detailed calculation. Find out what is the steam available or what is the amount of heat available in the steam produced and how much is the heat which we have supplied to the boiler. That can be calculated by the fuel flow rate and calorific value available with the fuel. This calculation will not be a very difficult calculation. This method of calculation will be called as direct method. So your energy audit of boiler will be employing a direct method of assessment. There can be indirect method of assessment wherein you will be calculating all the losses from the boiler, and those losses 100 minus those losses will be giving you how much is the efficiency of the boiler, and that will be known as indirect method of assessment. So let me give you a diagrammatic representation of the direct method of assessment. Fuel input plus air input, let us say it is going to account for 100% of the input given to the boiler. We are having water also, so whatever are the inputs to the boiler, air, fuel and water, calculate these are the inputs to the boiler, and what are the outputs from the boiler is output from the boiler are flue gases and steam output. We may not be accounting each and everything over here. We will be approximately doing the calculation, and the approximate calculation says efficiency of the boiler is heat addition to the steam multiplied by 100 divided by gross heat available in the fuel, and this efficiency calculation will be called as direct method of calculation of efficiency. However, this method has got limitation. This method is very simple to calculate. So eta boiler efficiency will be equal to Q into Hg minus Hf divided by Q into GCV into 100. Now, what does this Q stand for? The above Q stands for, capital Q stands for the quantity of steam produced. multiplied by Hg minus Hf, that is the enthalpy into the steam, minus Hf, that is the enthalpy of water, because you may not be supplying water at very lowest temperature, we will be supplying water at 25-30 degrees Celsius. So what is the enthalpy over there? Divided by small q stands for the flow rate of the fuel into gross calorific value of the fuel multiplied by 100. This will be simple calculation of the boiler efficiency. Now this can be done on a very regular basis in the power plants or wherever you are employing a boiler, and if you have a calculation done from time to time, you are doing audit of your boiler, easy audit of your boiler, and the moment boiler efficiency dropped down, that means your calorific value of the fuel may be lowering, so you'll have to have a check on calorific value of the fuel. From where are you getting the fuel? Is the fuel weight? So on and so forth. So all these control measures can be taken. So I have given you one calculation here. Those who are not done thermal engineering as a part of somebody, some your curriculum, etc. You can let us say quantity of dry steam produced is 8 ton per hour. Pressure is 10 kg per centimeter square at 180 degrees Celsius. Quantity of coal consumed is 1.8. Feed water temperature is 85 degrees Celsius. Coal calorific value is 3200 kilocalorie. Enthalpies, etc., have been captured from the steam tables. You must be wondering why I am taking the feed water temperature at 85 degrees Celsius. It means that we are employing economizer over in this utility. And the moment we are employing economizer in this utility, the efficiency is becoming 80%. Isn't it? The efficiency is becoming 80%. Otherwise, getting 85 degrees Celsius temperature without employing economizer, we may not be getting the efficiency as this much percentage. So let me tell you the advantage of direct method. The plant people can evaluate the efficiency very quickly by the help of this method. It requires few parameters for computation, and it requires few instruments for monitoring. So what you need to monitor is the water, the temperature at the end of economizer, water temperature at the end of economizer, steam pressure and temperature, and fuel flow rate. So if you just go back, whatever values we have noted here, very limited numbers are there. In fact, 8 ton per hour. So we should know fuel flow rate, we should know steam pressure, we should know quantity of coal consumed, the feed water temperature. Okay, these are to be monitored. And gross calorific value of the coal is available from the supplier to you. And normally in power plants and those water utilities which are employing coal in bulk, they have got a chemistry lab wherein they try to cross check the calorific value of the fuel from time to time. They may not be doing it on a daily basis, but they do it on a very regular basis. So calorific value is noted, and the enthalpies, etc., are noted from the steam tables, and automation has been done on this matter. So we can employ it with the help of automated systems also. Disadvantages of this method is we are getting to know that the boiler is 80% efficient, but where it is losing the 20% is not known to us. So it does not give clues to the operator as to why the efficiency is lower. Now, considering that 80% is lower and we would like to recover maximum out of this 80%, so why 80%? Why not 94%? Why not 93%? Where is the potential so that I can trap 13% extra? So that clue this method is not giving to me. And why this clue is not available with us is because we are not calculating the losses at various locations. So losses shall be calculated, and that is what is the advantage of the indirect method. So indirect method is also known as heat loss method. Now you may be saying that no, you are teaching or you are telling us not like a practitioner, but like a teacher. But then practitioner has to basically do the same thing. The practical energy auditing people will be basically capturing the data from the plant, and the plant may have got instrumentation already installed, and in case the instrumentation is not installed at various locations, the auditors are supposed to know, take the instrument to various locations and measure the temperatures, pressure, and then do the calculation uh, at the desk. So they are basically supposed to do the calculations like no, we do during our student days, or teachers no do calculations for their no question papers. So energy accounting and energy calculations, you just cannot get rid of the calculation technique. In fact, let me tell you here, there was a program sponsored by European Union for India, which is was called as Energy Audit Bus Program. And these people had energy audit bus program. European Union has supplied us certain instruments which were housed in a bus. Uh, that is a vehicle, and that vehicle was having all these probes, etc., installed. And these buses will go to various plants. If at all the plant is having instrumentation installed at various locations, then there is no problem. Otherwise, the energy auditors will probe put the probes of the instrument at various locations, take the measurements, and sophisticated instrumentation was basically calculating the efficiency, and whatever calculations I am putting in front of you by the help of no certain programmable gadgets. So that was called as the energy audit bus program. So you simply cannot get rid of the calculations, etc. Now here we are trying to measure many things into the boiler house, which is called as indirect method of calculation or indirect measure of measurement of the efficiency of boiler. The purpose here is we should not only know the efficiency of the boiler, also we should know where all the losses are happening. The idea is if you come to know that there are losses at this location, we may make an attempt to control that losses. I am now tempted to tell you here, why don't you do this kind of technique in our day-to-day practices? You just try to know, note down how much money you have earned during a month and where have you have spent the money during the month. Make a record of that. Okay, you will come to know that at the end of the month you have spent substantial amount of money on medication. That means you should take care of your health. Or if you have spent substantial amount of money on say entertainment and hoteling, maybe boozing, that means you are losing a lot of money over there, and it is high time that you can control and you can probably save the amount over there. Like that, you should try to find out where all the energy inputs given to the boiler are going. If they are going, if you can calculate that, you can control that. So the efficiency can be arrived by subtracting the losses. So losses in dry, now what kind of losses can be calculated? Losses in dry flue gases, losses due to moisture in the fuel, losses due to combustion of hydrogen, because hydrogen will be converted to water, heat loss due to radiation, all the fuel may not be burned, there will be blowdowns which will be happening into the boilers, which are necessary in the boiler. So all those calculations if you try to do, you will be doing the indirect heat calculation. So the heat input, even if let us say assume it to be 100%, which is given by air, that is nitrogen and oxygen, we may have moisture and ash in the heat, which we may have moisture and ash in the uh, as an input in the fuel. Then we have to supply water. However, the water comes out from the has to be vented out from the boiler as a blowdown, because Otherwise there will be scaling on the tubes of boilers. So how much is the heat loss which is happening in the blowdowns? Bottom ash losses, how much is the ash which is going as a slurry? How much is heat which is going into the steam? How much are the dry flue gases? How much is the hydrogen loss? How much is the moisture in the fuel loss? How much is the moisture in the air loss? How much of the fuel is getting converted to carbon dioxide and how much is getting converted to carbon monoxide? If at all any ash is going out as a fly ash, how much is the heat taken away by fly ash? How much is the flue gas which is taking away the heat? How much are the losses which are happening from surfaces? If you calculate all those things, efficiency minus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, this method will give you calculation which we call it to be indirect method of calculation. Now what is the advantage of this method is we are getting the efficiency of the boiler, but we are also accounting for where are the losses happening. Where is the loss 1? If the loss 1 is more, let us try to control it. If the loss is, let us say, blowdowns are happening too much, if the surface losses are 6, number of losses are less, that means what we can do is we can basically insulate the boiler better, like that. So this way, if you just do it for indirect accounting, now I am showing you certain calculation over here. This indirect calculation method will require, however, large data. So this we call it to be, indirect calculation, better monitoring, and this we call it to be detailed energy audit. The direct method of calculation, we can call it to be as direct method of calculation. We can categorize it into, say, preliminary energy audit technique, and detailed method of analysis. If you do, we can call it to be detailed energy audit, basically. So I think I have stopped sharing. Huh? Is it visible to you?
No, sir.
I think some.
No, sir.
Okay, I am sharing once again. Huh? Is it visible now?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Is my okay audio is clear? No. Okay. Is it understandable whatever I am telling?
Yes, sir.
Okay. Now let me tell you that the detailed energy audit of boiler will require large amount of data, and a large amount of data starts from ultimate analysis of the fuel. So we need to do the fuel analysis. We know ultimate and proximate analysis of fuel, so we'll have to do detailed analysis of the fuel. We must know how much is the hydrogen, oxygen, sulfur, carbon, ash content in the fuel. Percentage of oxygen in the flue gases is to be known. Flue gas temperature should be known, ambient temperature to be known, humidity of air to be known, then gross calorific value of the fuel to be known, percentage of combustible in the ash to be known, and gross calorific value of ash also to be known. So if you capture more and more detailed data from the boiler house, you can do indirect calculation. So then this method of analysis will result into finding out not only the efficiency of the boiler, but to find out where all the heat losses are happening. So how can you calculate the sensible heat loss which is happening in the flue gas? Simply mcp delta t. How much is the flue gas which is going out? Cp of flue gases can be taken as equivalent to air. The higher the flue gas temperature, higher is the losses in the flue gases. So the moment your flue gases mass flow rate is higher and the moment your flue gas temperature is higher, the heat losses in the flue gases are going to be higher and higher. And it goes without saying that lesser is the heat in the flue gases, more and more efficiency can be captured. Now, and the pollution control board is also preventing us from venting out the flue gases. So what we should do is, we should not vent out the flue gases just like that. We should try to recover the heat as much as possible from the flue gases. Now, how can you capture the heat? The heat can be captured primarily by the superheater, secondarily by the economizer, tertiarily by the air preheater. And if I cannot capture it beyond that, then it can be vented out. So this way, the flue gas losses through the chimney can be reduced. Then comes convection and radiation losses, which is can be calculated by simply Stephen's law. And lesser the surface temperature of your shell of the boiler, lower will be convection and radiation losses. And in general, poor insulation will be poor insulation or broken insulation will be resulting into the radiation losses. So better insulation to be put. And you just cannot control the temperature in the hearth of the boiler. So, and you cannot control the outside temperature of air also. So what you can control is what is there in the hands of the utility engineer. Auditor will be calculating the efficiency, inefficiency and losses, and he or she will be giving the feedback to the operating personnel, and it's the job of the operating personnel to put insulation at proper places. Unburned matter in the fuel. How much is the carbon dioxide production in the chimney gases? Lower is the carbon dioxide, lower is the temperature of chimney gases, or then you can control the unburned matter. In fact, you can have a control and monitoring of the unburned matter in the flue gases. If you look at the chimney gases, they should be just violet in color, just violet in color. If the chimney gases which are going out of your boiler or any furnace, they are very dark, having more amount of soot, what does it indicate? It indicates that the flue gases are containing more and more percentage of unburned matter. And the chimney gases, if they are hazy in nature, cloudy in nature, whitish in nature, that means we are supplying extra heat, extra fuel, extra water, no, extra air basically, not extra heat or water, extra air. So the moment your forced off fans are supplying extra air, whatever is the heat, yeah, any difficulty there? Am I audible?
Yes, sir.
Yes, sir, you're audible.
Okay, sir, there was some disturbance. Okay, the moment you supply more and more air, the moment your forced off fan in the boiler supplies more amount of air or air at higher flow rate, the heat which is supposed to go to the boiler feed water will not go to the boiler feed water. It will be taken to the chimney gases directly, which is again a loss. And the moment you are not supplying enough quantity of air, then your chimney gases will appear to be blackish in nature. And those blackish chimney gases in nature will be again indicating that you are not supplying proper quantity of air. Both the cases are wrong cases. So your chimney gases, visually if you try to inspect, they should be just violet in color. They should not be hazy and they should not be dark in color. And detail accounting can be always done. Okay, then one more trouble in the boiler or energy auditing or the boiler troubles us is the blowdown. Now this blow down function also you must have heard and learned earlier. Because the water deposits make scales deposit onto the tubes, and the moment there are deposits onto the tube, the heat transfer coefficient decreases, so it decreases the efficiency of the boiler, and we need to vent out all these scales from time to time. So there is a technique called as blow down techniques. So 3-4 times during the entire day, we may go in for blow down. So suddenly you have to vent out the steam from the boiler. This function is called as blow down. And you need to optimize the blow down. That means if you do more and more blow down, the the tubes will be free from scaling. However, it will be directly losing the you will be directly losing the heat to the atmosphere by the process of blow down. And if you don't vent it out, then what will happen is the scales onto the shells will be and tubes will increase. That will further reduce the efficiency of heat conversion. Now everything depends upon the total dissolved salts into the water, and we cannot say blanket 3 times, 4 times, 6 times, 8 times, like that. It all depends upon what kind of water is being used for the purpose of that as a boiler feed water. Now you can do estimation in this fashion. uh, Boiler drum is there, F is the makeup water, and we also get a loss of water when we are doing the feed water. So you'll have to add extra water. So what is the quantity of extra water? Mf, and 1 minus m is the condensate. Then Ws is the steam rate. WBD is the blow down rate, and you need to do a small calculation. In fact, those calculations are shown over here. F is the feed water in ton per hour. Cm is the concentration of TDS in the makeup water, concentration of TDS in the feed water, concentration of TDS in the blow down. M is equal to weight fraction of makeup water in the feed water, and you can calculate the TDS balance. And how much is the heat loss which is happening because of blowdown, that can be calculated. Normally about 4 to 5% of the heat is getting lost in the blowdown, but then this is a ballpark figure which I am telling. Normally 21-22% of the heat is getting lost in the chimney gases. Normally through 3 to 4% is getting lost into the blowdowns, so on and so forth. But it all depends upon what kind of boiler, what kind of pressure we are employing into the boiler, what kind of steam, what kind of insulation, and what kind of monitoring we are doing into the boiler. Then you will be calculating the heat input to the boiler as calorific value of the fuel plus this long calculation. Then heat output will be calculated. How much is the heat captured in the economizer? That is, it is basically simple enthalpy calculation. Enthalpy available at the end of economizer minus enthalpy available into the feed water multiplied by the feed flow rate. This will be heat pickup in the economizer, heat flow picked up in the boiler, heat picked up into the superheater, and all the heats added will be basically the total heat captured by the feed water and divided by whatever is the enthalpy of the or total enthalpy supplied. That will be giving me the heat output. Here you are accounting the enthalpy content given by or the heat captured by economizer, boiler, superheater, etc., etc. In fact, we can make two parts. We can make two parts of the superheater: convective superheater and radiative superheater. But then this should be weighed against the heat which we can be captured. Then losses can be calculated in the flue gas. The simple formula mCp delta T. How much is the heat loss in flue gases? That is m dot of flue gases, Cp of flue gases temperature of flue gases minus temperature of the flue gases entry and exit. Then heat losses due to moisture, heat losses due to fuel in the moisture, how much is the loss in combustion, that can be calculated, how much is the losses due to carbon monoxide, that can be calculated. In fact, whatever I am presenting in front of you is available on the Bureau of Energy Efficiency website, and they have made standard books for energy auditing of various utilities. So energy auditing of boiler, energy auditing of furnaces, energy auditing of ceramic plants, cement plants, and these calculations have been simply taken from the textbooks. Anyway, I am going to share the slides with Dr. Kaya also. You can ask him and use it wherever you want to use it. It's not a proprietary material. So this way we can calculate the losses and find out where all the losses in the are happening into the boiler. Now, after you have calculated the losses, you can find out and you can deduce the measures of saving. In fact, there is a methodology known as, I don't know, in the program you might have heard this technique. The technique is known as Sankey technique. Sankey diagram you have to draw. Energy balance of a particular utility is to be drawn, and there is a diagram which can represent all these things. That diagram is known as Sankey diagram. Now the Sankey diagram will tell us that 100 units of heat are added to the boiler and where all the losses are happening. Such a losses will be having 100 units added from on one side, and where all the units are getting lost. Let us say you come to the know that 23-24% of the heat is lost in chimney. Blow down as against 3%, 2% losses, you are losing say 5%, 6%. Sankey diagram, a diagrammatic representation will tell us how much is the loss. Now imagine a situation that your losses are on a higher side. You have done accounting or auditing of your boiler. Then what are the measures? There can be certain measures which we can call it to be housekeeping measures. Housekeeping measures means those measures will not require any amount to be spent. There will be certain measures which will be requiring very less amount of money to be spent. This will be called as short-term measures. There will be certain measures which will be requiring a moderate amount to be spent because you need to modify the boiler. You need to additionally equip the boiler with additional kind of gadgets. These are called as medium-term boilers, medium-term measures. There will be certain measures which will be aimed at, which will be requiring complete overhaul of all of the systems, like completely changing the pipings, etc., etc. Those will be known as long-term measures. Now let me tell you few measures. Long-term measures will definitely require more investment, more time of recovery of the investment, more commissioning time. Short-term measures or housekeeping measures will not be requiring any time. In fact, housekeeping measures will not require anything. They will require just to change the operating practices. So reducing the excess air is an housekeeping measure. How come? The moment you get to know from the boiler that your chimney gases are very hazy in nature, that means you are supplying extra air. So reduce that air, your efficiency will improve. Reduce the convection and radiation losses. The moment your shell of the boiler is very hot, it is dangerous to the human being which are working in the vicinity of the boiler. Also, you can calculate it by the help of the calculation technique which I have shown you. Repair the insulation breakage. This will be known as a short-term measure. If the breakage is larger, it will be a medium-term measure. Insulation repair and overall can never be a long-term measure. Ensure proper combustion of the fuel will be housekeeping measure, because proper combustion of the fuel will require to monitor the air supply to the boiler, reduce the if at all the excess air is larger, you'll have to reduce it. If the excess air is not larger or insufficient, you will have to basically supply sufficient amount of air. So this is a housekeeping measure. Reduce blowdown losses, it will be housekeeping measure. Ensure damper control operation is efficient. So if you do not want to repair the damper, then it will be housekeeping measure. If you want to do minor damper repair, it will be very short term measure. Avoid fouling, this will be medium term measure, because you may have to treat the water by the help of some water treatment process. HRSG, that is heat recovery steam generation. I have started this talk with the air preheater economizer superheater kind of job. So the air preheater economizer superheater, these are known as heat recovery steam generation purposes or steam generation issues. Unutilized energy in the boiler in the form of high temperature exhaust gases normally leaves the boiler, and that is where you can save a large quantity of energy which is going lost, and this is called as HRSG, that is heat recovery kind of system. This can be, if you can capture it, then your boiler will become efficient. If you cannot capture it, then what you can do is the boiler can be utilized as a pressure boiler or power boiler to begin with, and the waste heat which is going from the boiler, if you can connect it to the process heating, that plant will become a cogeneration plant, and your entire utility, you can save lot of energy in your utility. In fact, there is a formula, eta 1, there is the overall efficiency of any thermal utility is eta 1 plus eta 2 minus eta 1 eta 2, that kind of formula. I am not recalling the exact formula, that is for cogeneration. If you do cogeneration, the overall efficiency of the plant increases. Now let me tell you a few case studies here. I am just catching the extract from few case studies which the Bureau of Energy Efficiency has given to energy auditors and given to general public in their website and given in their booklets. There is a case study available wherein damper control was exercised. So maybe there was no control over the supply of air, oxygen to the combustion purposes, and since there was no control, not much could have been done. So by exercising better dam control, oxygen in the flue gas was brought down from 14% to 9%. Now imagine a situation that there was a loss which was happening in the chimney. 14% oxygen is going away in the chimney gases. Normally the oxygen is supposed to take part in the combustion, and what we should get in the chimney gases is carbon dioxide or carbon monoxide, not definitely oxygen. And here we were finding out that the oxygen in the chimney gases was 14%, so it was brought down to 9%. How come it would have been brought down? By cutting down on the air supply, and correspondingly excess air was brought down from 200% to 75%. Here they might be saving the excess air for combustion purpose in very large quantity. Earlier it was 200%, it was brought down to 75%, and the boiler was using basically a waste fuel which was the coconut shell, and the coconut shell consumption was reduced by 5%, and the annual saving which was happening in the plant was 3.5 lakhs. Now you may say coconut is a throwaway matter, and 5% saving in the coconut shell is not a very big deal. But imagine a situation that you are burning a very precious coal, you are burning oil, you are not burning a biomass which is just a coconut shell, then your energy saving and amount of money which you have saved through this controlling measure was substantially large. And it's not only making your efficiency better, you are saving the environment from thermal pollution. And pollution control board is very particular about it. You may have extra money in your pocket and you may like to burn currency notes, but no, pollution control board is not going to allow us to burn even currency notes. Why? Because then you will be increasing the temperature of the chimney gases which are going venting out from your boiler, and the globe is global and warm is warming, isn't it? So if everybody gives away the chimney gases at higher temperature, there will be global warming, and the global warming will be finally resulting into loss of environment, which we should not do. So energy and environment always go hand in hand. There is one more example here: installing economizer to a boiler. A paper mill retrofitted an economizer to existing boiler. The specification of the boiler is 8 ton per hour boiler. Feed water temperature 110 degrees Celsius. Pressure was 18 bar, that is moderate pressure boiler. Fuel oil was being used. 10,000 kilocalorie per kg is the calorie value of the fuel. The thermal efficiency of the boiler was measured and it was calculated by indirect measure. And now let me tell you one more thing. In fact, I was about to tell you the instruments, but then I think somebody has already covered the instrument. There is a flue gas efficiency, flue gas analyzer. Very handy gadget is available. You need not do all this calculation. You can simply insert the probe, and the flue gas analysis is done, which tells us the indirect efficiency of the boiler, and it was found that the thermal efficiency of boiler was 81%. The flue gas temperature was 315 degrees Celsius, and dioxide percentage was 13, and CO was 167 ppm. The temperature of flue gas, which was 315 degrees Celsius to 320 degrees Celsius, the waste heat in the flue gas was recovered by installing an economizer. Economizer means we are heating the feed water. This resulted in the rise of feed water by 26 degrees Celsius, and the average quantity of steam generated, which was 5 ton per hour, 315 degrees Celsius flue gas temperature. Average steam generation was 14 kg per hour. Average steam generation per kg of fuel oil was 14 kg. Feed water intake temperature was 110 degrees Celsius. These are the calculations. Fuel supply rate was 314 kg per hour. Flue gas quantity was found out. Cost economics was calculated. Quantity of flue gases is 5463.6 kg per hour. Quantity of heat available in the flue gas is mcp delta T. Rise in feed water temperature is 26 degrees Celsius. It resulted into calculation 130,300 kilocalorie per hour. Saving in terms of fuel oil was calculated 13 kg per hour. If annual operating hours of the boiler are 8,600 hours, how much kilogram of fuel oil was consumed, saved? 11 lakh 1,800 kilogram of fuel oil was saved per annum. This much quantity of fuel oil saving must have substantiated or must have given a substantial amount of saving. So through the recovery of waste heat by installing an economizer, the paper wheel was able to save 13 kg per hour of fuel oil, which amounted to 1,11,800 kilograms of fuel oil per annum. This is the miracle of energy auditing. I don't know why. Okay, so two examples I have shown. One example was very simple, wherein the calculations were not difficult, but the other example was having little longer calculations. Some of you might be feeling that no, after lunch, 2 o'clock, 1 o'clock, how do I digest this calculation? These calculations are not much difficult. Simply MCP delta T. Combustion in boiler and energy saving opportunities without investment is one more case study in front of you. I told you we are supplying air plus fuel to the boiler. We are taking heat from one side and exhaust on the other side. You can have natural gas burners. Now I am talking about normally we can have coal fired boilers, oil fired boilers, or gas fired boilers. So here we are talking about gas fired boilers. So naturally gas burners are there, oil burners are there. So this kind of stoker coal furnaces, cyclone furnaces, pulverized coal furnaces, and fluidized bed furnaces, especially when you are converting and burning the solid fuel, the coal furnaces play a vital role. Now, if you look at this calculation, you will come to know that the generation efficiency of the boiler house was 80%. Uh, by efficiently in doing it, if you look at this middle part of the story, the distribution efficiency is 83%, and utilization efficiency of the steam is only 47%. In fact, this can be one more topic on which somebody must have spoken or should speak into the entire steam system. We may generate the steam properly, but we may not distribute the steam properly, and we may not utilize the steam properly. Isn't it? Generation is important, distribution is important, and utilization is also important. If you just compare this with a power plant, uh, we must generate electricity with highest possible efficiency in the power plant. But transmission distribution should be done properly so that losses are minimized. And your gadget should also be efficient so that your utilization efficiency is proper. Then only we'll be doing a justice of finally the consumption of the end users getting reduced. Same is the story with steam generation. If you at all you are wasting the heat while utilizing it, utilization efficiency is less. Whatever you might have saved in the generation or whatever you might have saved in the distribution will be subsequently lost. So is the situation in distribution. The distribution line of steam has to be proper, and proper generation and reducing the losses in generation of steam. I have spoken at length for say no more than 1.5 hours. These boiler losses I have already covered, so I will not speak much about it. Loading of boiler. This is a graph. We should load the boiler optimally. 60 to 80% to 100% load on the boiler if you give, the boiler will be producing better efficiency. And this is called as housekeeping measure. If you just look at this tabulation, somebody has calculated this and told us that if you can have excess air, more and more excess air will be having more and more losses. And how much should be the excess air in terms of which fuel? Natural gas, oil, residue oil, anthracite coal. Normally we are having anthracite coal. So percentage of excess air, there these kind of tabulations are available, with the help of which we can know how much should be the excess air to be supplied. We should also have one of the energy conservation measures is to get rid of the soot on the pipes of the boiler generation or the steam generator. Otherwise, the soot and the scales, they basically make the boiler inefficient. So soot deposition also increases the flue gas temperature, and soot shall also be reduced by the help of scrubbing, etc. from time to time. Feed water temperature should be increased as far as possible so that your efficiency improves. Combustion air temperature increases by the help of air preheater, your efficiency of the boiler increases. Cleanliness of boiler. See, there is a comparison available here wherein you are having a clean boiler and you are having a boiler which is a dirty boiler after 6 months. A clean boiler, flue gas temperature is 220. A dirty boiler after 6 months, without much cleaning of the boiler tube, the flue gas temperature is 300 degrees Celsius. Isn't it? And it increases the efficiency, which was 88% earlier, has reduced to 84%, and it increases the annual heat losses from your boiler. So brushing the gas tubes with the help of scrubbing mechanism each month has to be done. Like we are brushing our teeth every day, something like that we have to go for scrubbing. This is low cost energy saving measures which can be employed. Maximization of combustion, maintaining cleanliness, repairing and replacing insulation, insulating feed water tank, insulating condensate return lines, excess air reduction, all result into better efficiency from the boilers. Damper control. This is a case study of a Thermax boiler. Thermax is leading producer of boilers. Damper control. If you open the damper more and more, you supply more and more air, and excess air basically rents out the purposeful heat to the atmosphere. And if you don't open the damper, then you don't supply proper quantity of air. So controlling the damper properly can result into optimized efficiency of your boiler unit. By damper control in oxygen, flue gas was brought from 14% to 9%, and annual saving, I think I have told you the story earlier, 3.5 lakh rupees by simply controlling the damper was found. Now this is where I end up with the boilers, and if you are having time, I have got one more case study in front of you, but then this study is not for boiler. This case study is for the re-rolling mill. I think this case study I will not cover. I will cover two small case studies which will take about say more than about 15 minutes time, and if time permits, we will go for this case study. National steel mill in Singapore has gone for certain measures. So that accounting I was about to show you, but then since we are on boiler and furnaces and utilities, let me just go towards that. This is a case study from Shri Cement Limited. If you recall, I have told you to begin with that cement industry, chlor-alkali industry, power plant, then sugar industry. These are basically industries. Glass, ceramic industry. These are energy intensive industries. So Sri Cement Limited case study, small case study is there, wherein they have tried to exercise small things which are resulted into substantial amount of energy saving. This case study again thinks about a preheater being used. So you can see the steel industry having six floors are there, and the temperature in the chimney gases is found to be uh, very large. and there was somebody has done a mischief. The preheater was insulated, and insulating the preheater is something which is not ethically correct also, because our job in the air preheater is to ensure that maximum heat from the flue gases should go to the preheating of combustion air, and if you just put insulation there, then there will not be proper heat transfer. So what these people have done is, these people have removed the preheater. If you just compare these two figures, the temperature of chimney gases was 395, and here the temperature was 391, and after removal of this insulation from the preheater, the temperature of flue gases which was otherwise venting out, uh, it should have been brought down to 376. They were not in a position to bring it down to 376. They were in a position to bring it down to 391. Just 4 degrees Celsius temperature change, for which the installation commissioning of the gadget may not be very useful. So insulation was villain or a barrier in the recovery. So the moment they have put insulation, they have removed insulation, the temperature has got to 376 degrees Celsius, and it has resulted into substantial amount of energy saving. Before and after of insulation, the preheater outlets quantity of the gas in meter cube per hour was 2,10,000 meter cube per hour. 395 degrees Celsius is the outlet temperature of chimney gases. Earlier, the gas was going out at 391. It was brought down to 376. So 19 degrees Celsius temperature difference was made, and outlet gas temperature was 180 degrees Celsius. Calculations are made, and the power difference was found to be there, and the all calculations are shown here in front of you. It has resulted into a substantial amount of saving. It is not available in terms of money, but in terms of quantities of heat, etc., this is very much available with us. So what was the mistake? The mistake was, on the left hand side you can find out that there was insulation over the ducting, and the insulation was removed onto the ducting, and it has resulted into saving. It is resulted into water consumption and power consumption. And how much was the amount of investment made? Just 40,000 rupees, and the payback period is calculated. See, this is also one technique. We calculate a payback period of the measures which we are employing. How much is the amount of money spent on the energy conservation measure, and how much is the saving in terms of amount of rupees. If you just find out within how many days or within how many months we can recover the money. If it is 1 month, 2 months, less than 1 year, it is supposed to be recovered on a fast track basis, and these measures are known as short term measures or housekeeping measures. In fact, 1 month recovery time, I would call it to be a short term measure. The same thing was implemented in another unit, and it was found to be very large. So I don't know why they were putting insulation at wrong places. There's another case study. Furnace lid was not covered with the help of a lid. A furnace which is containing, say, 1500 degrees Celsius temperature of molten matter was not covered with the help of a lid, and ambient temperature is 30 degrees Celsius, and the emissivity of that molten matter is 0.7, which results into a substantial amount of energy loss and radiation loss, rupees 1.6 lakhs. So just covering it the help of lead, and the lead may not be costly, has resulted into a substantial amount of saving. So like that, there are several case studies available. Okay, I have finished the bare minimum case studies which I want to, examples which I wanted to give you. Any questions till now? And if there is a time, we will take up that National Singapore meal case study.
Yes, sir, you can continue with the case study. We will ask question at the end of the session.
So about 15-20 minutes are there with us. Huh? No problem.
Yes, sir, yes, sir.
Okay, I will take the Singapore case. Do you like the cases?
Yes, sir.
Okay. Okay, just let me go to the National Singapore Meal case study. This is a published case study in a very high profile journal. So we have paid amount for purchasing this case study. Basically, there is a national iron and steel mill in Singapore. This is not a boiler case study, by the way. This is not a boiler case study, but a thermal utility case study. There is a national iron and steel mill in Singapore. Normally, whenever you are presenting any energy audit matter, who is writing?
Hello.
Who is writing
Hello.
over there?
Ratna,
Kajal madam,
Ratna madam.
Yes, sir.
please restrict the outsider.
Sir, there is no outsider we have taken.
No, somebody is writing, somebody has used the board and somebody has written onto the slides, basically. Okay. So don't allow anybody to write down any unwanted matter. Otherwise, we'll have to stop discussion over here. I stop sharing.
So please wait for a minute.
Okay. I have stopped sharing so that
Yes.
people cannot do any mischief.
Yes, sir. Yes. Ratna madam, please.
Sir, have you
make
done
me a
another
co-host.
login by the
Yes.
name MCTRGIT?
Yes. That is me. Please
Okay.
make me the co-host.
Okay. I have made you co-host, sir.
Hello. Ratna madam,
Yes, sir.
make co-host to the Rehan sir.
Yes, sir. Sir, I made him co-host.
Okay, shall I continue?
Yes, sir, I have made him co-host.
Yes, sir. Yes, sir. Please continue.
Okay. Okay, so this is a national iron and steel mill in Singapore. Now, this is not a boiler case study, but then this is a furnace case study. But then the losses of efficiency, etc., are covered over here. Now, what I want to tell you here through this case is that whenever you make any detailed energy audit report, because the industry is working in a say very busy environment, you'll have to give executive summary. So I don't know whether it has been covered into your energy audit program or not. There is a typical style of presenting the energy audit findings to the board of management, etc., board of directors. So the first few pages are dedicated, which is called as executive summary. Now, executive summary, we describe what kind of industry was there, what kind of energy consumption annual was there, what kind of specific energy consumption was happening in that industry, and what kind of measures are found suggested in the industry, and what kind of costing is required to be done, what kind of investments are to be done, medium term, short term, and long term in the industry. So here this slide is presenting in front of you a partial energy consumption case study, partial executive summary, which is telling you the executive summary. So specific energy consumption in this mill was 1095 kilowatt hours per ton. That means they were using 1.09 kilowatt hours per kilogram of steel produced, which is not very high number. That means this mill is efficient, but not that efficient. We could have reduced it to 0. 0.7, 0. 0.8, 0.9 kd per kilowatt hour per kg. So ideally speaking, that 1095 could have been reduced to 900, 700, 800, like that per ton. They have suggested major consumer. They have found out electric arc furnace is found to be the major consumer, and reheating furnace was found to be the major consumer. And efficiencies of these are found to be 50% and 60% respectively. So major energy consumption gadgets are found. Then the next page is then any energy audit report of the mill. A steel scrap is there, the scrap is preheated, then it goes into an electric arc furnace. Then there is a ladle means where the scrap is put and it is melted there, and that ladle is preheated. Then there is another gadget called as tundish. Then we go in for casting, and then we make something called as billet. Billets are nothing but uh, bigger iron blocks which are square and not much long in nature. ठोकळे तयार करतो आपण. And then the billets are gone to store, and they may be reheated. Billets may be reheated. They may be rolled to make a final product like strap, steel strap, or stranded bars, or whatever kind of any steel mill basically produces the billets, bigger blocks, and then final product is in terms of strands, etc. Then what kind of energy is given over there? So here E stands for electricity. Wherever we are supplying electricity, wherever you are supplying diesel, wherever you are supplying air, these are shown over here. And wherever there is a exhaust gases going out, they are shown by EG, isn't it? So this way EG stands for exhaust gases. So which kind of inputs are given to the entire process, they are shown over here. So preheated ladle, the exhaust gases are given to the scrap heater, isn't it? So like that we make some layout of the mill. Otherwise it's you cannot simply make a very descriptive discussion of the mill, because the board of directors and management may not have time to read your complete energy audit report. which you will have to give it in the form of a chart of this type. It is a sample chart, which is a published chart in a very big good journal, which I am presenting in front of you. Then there are sub processes, their energy uses and costing. So arc furnace, casting, ladle, tundish, reheating and rolling, these kind of utilities are there in the mill. And which kind of energies are being used? Electricity, fuel oil, diesel oil, electricity. These kind of energies are being used over there. How much is the energy used? Kilowatt hour per ton. In fact, I would say specific energy use has been tabulated over here. There must be very big calculations and big report at the back end, but then these are in brief put before you. Then their energy costs are also put in front of you in the tabulation in US dollar per ton. Then we calculate, this is called as a Sankey diagram. I was speaking to you something called as a Sankey diagram. What kind of inputs are given and what kind of efficiencies are involved and what kind of losses are involved. That diagram we call it to be Sankey diagram. So the purpose here is not to know the entire, how these calculations are made. Slag is taking 6.5% of energy, exhaust gases are taking away 12.8% of energy, 4.6% of energy is going others. The molten steel is taking away 50.6% of energy. Its temperature is quoted. The entire absolute quantity of energy which is there in the molten steel is given. Then cooling water temperature is given and heat is taken, heat percentage is given. Like that, variety of quantity of heat in absolute and percentages of the input are given, which is called as a Sankey diagram. And here the author here is it calling it to be as a micro analysis of the energy. Because the steel mill is very big, a diagram has been drawn for electric furnace. A diagram of this type has been drawn for ladle, then tundish, and then preheated tundish, so on and so forth. So imagine a situation that you are handling audit of very big industry. You will have to break it into small operating units, and you will have to draw Sankey diagram for small units. Then casting machines, then billets, all those things. So how much is the amount of heat given and how much is the amount of heat taken away and how much is the loss. So all those things have been very diagrammatically shown. So such a report shall be made ideally by the auditors whenever audit report is being presented to the board of directors. All quantities and percentages. Motors are giving this much, pump is giving this much, reed furnace is taking away 2.9%, cranes are taking 1.6%, like that. Now they have suggested few measures. Scrap quality control. Whenever any steel mill is operating, they do get scrap from anywhere and everywhere. And non-metallic scrap takes away large amount of energy. And that is what their energy finding measure. And 1.5% of iron loss happens because 1% of non-metallic scrap is being collected. So the scrap collection has to be proper. It increases 15 kilowatt hours per ton of electricity and it increases 0.2 kilograms per ton of consumption. So scrap should be controlled properly. That means your input has to be proper. Furnace charging practice. Now, how do you charge? Basically, whenever any steel industry is there, you have to preheat the furnace. And if you just keep it charged every time, and if you do not allow the furnace to become cool, that increases the efficiency of the entire operation drastically. So reduce the cooling time and reduce the charging time. That is one of the measures. why don't you preheat the scrap? We have talked about preheating of the water, etc. in the boiler. Here we are talking of the metal. So lower melting cost, standard increased productivity, and reduce electrode consumption, and basically we can substitute it with the help of some other fuels, and we can get substantial amount of energy saving by scrap preheating. Ladle refining increases the efficiency, and the solution provided was billet charging, hot billet charging. Preventive maintenance should be done. Inefficient furnaces shall be replaced. Fuel oil preheating was suggested with the help of another Sankey diagram. It was found that the mill was only charged twice, and third shift the mill was not used. So third charge of the arc should be used. Optimum production rate. So instead of having 3-4 mills, if you just reduce the number of mills and run all the mills efficiently 24 hours and recovery of wastage, you can get say better efficiency. So this is a very good, and I have put in a nutshell uh, the case study of a iron and re-rolling mill, a steel mill in Singapore. So just to sum up, the purpose was to put before you the energy conservation in boilers, but then boiler is the indicative thermal efficiency. Majority of the inefficient gadgets in the boilers, similar gadgets are found in furnaces, similar gadgets are found somewhere else. Similar energy saving measures like insulation damage, preheating, heat recovery, which are very prominent in boilers, can prominently be used in say process mills like cement, steel industries, and variety of utilities. With this one, I conclude it's 5 minutes to 3 o'clock. So 1 to 3 o'clock, 2 hours we have consumed almost. If there are any questions, I'll be answering them.
Thank you so much, sir. Indeed, it was a session filled with knowledge. Now, with your permission, I would like to take up the question answer session.
Yes, please. Yes.
Good afternoon, sir.
Oh,
Ah,
Good
yes,
afternoon,
yes.
sir. Sir, there is this question.
Yeah.
What are the limitations of direct method of boiler efficiency calculation over indirect method?
Direct method will be giving quick calculation but approximate calculation. Whereas indirect method will be giving you detailed calculation, but then it will require too much information.
Okay, thank you, sir. There's another question, sir. When steam is supplied from boiler to different parts, is there any pressure drop?
Yes, in fact, that topic I have not covered because see, boiler is a utility, such a utility in the entire plants that we have to think of generation, efficient distribution, and efficient utilization. So if you are distributing the steam properly, the steam is having a tendency to condense, and a condensed steam will have what low enthalpy. So what we have to do is we have to basically recover the condensate and allow only the steam to go ahead and recover the liquid and get the liquid back to the boiler. These are called as condensate recovery systems or steam traps. But then I have not covered, and because of paucity of time, we could not cover it. So distribution is also one thing wherein all auditors have to basically pay attention to.
Thank you so much, sir. Thank you so much for your guidance. Now I conclude our question answer session. Over to you, Chetan, sir.
okay. Now I request Professor Mukund Valse to give vote of thanks.
Hello, am I audible?
Mukund sir,
Yeah,
over to you.
audible.
Yes, sir.
It is my privilege to propose a vote of thanks on this occasion. I, Professor Mukund Valse, On behalf of MCT's Rajiv Gandhi Institute of Technology, Department of Mechanical Engineering, and on behalf of organizing committee of AICT AQOS sponsored online short-term training program phase 2 on recent trends in energy management and audit, and my own behalf extend a very hearty vote of thanks to Dr. Sanjay Pohekar sir for accepting our invitation as a resource person and sparing his valuable time with us. He has given a good insights on the topic of energy saving in boilers and thermal utilities. He has covered the points such as types of boiler and its accessories, role of operating parameters on the energy efficiency of boiler system, optimal boiler operation strategies from the energy efficiency point of view, performance assessment of thermal utilities, direct and indirect method of improving the boiler efficiency, combustion in the boiler and energy saving opportunities, type of combustion system, and a very few very important case studies. Thank you so much, sir, for your great session. Today, as we have completed the phase 2 of short-term training program, we will circulate the test to Google Form link by today. Kindly attempt and clear the same as requested by the AICT guidelines. I would like to tell you that we have a phase 3 of AICT AQS sponsored online short-term training program on recent trends in energy management and audit, starting from 7th December to 12th December 2020. I request all the participants to join the phase 3. Thank you everyone. Also, we are very thankful to management of MCT's Rajiv Gandhi Institute of Technology, Mumbai, our principal sir, Dr. Sanjay Bokade, for giving us an opportunity to organize this event. I am also thankful to the head of mechanical department, Dr. Rajesh Kale sir, for his valuable guidance and support all the time. Thank you so much, all the members of organizing committee. Thank you, and thank you so much, everyone.
Yeah. Okay. Let's close.
Okay, now I would like to request our technical team